Hi, everybody. This is Dr. Nigro with a Chemistry Notes screencast. This one is going to be the third in my set on mole conversion problems. My other two looked at the conversion between moles and particles and the conversion between mass and moles. Both of those were one-step problems where you had one conversion factor. This screencast is going to focus on moving between particles and grams. All right, so to make that conversion, we're actually going to have a two-step problem here. All right, so there'll be two steps here. One will be going from the particles to the moles, and then in the second, from the moles to the grams, or going from the grams to the moles, and then the moles to the particles. The key for both of those is the first step is always converting to moles of the substance. And then you can convert to grams, or then you can convert to particles. But first you have to be in the mole. All right, so let's go down to our organizers. All right, and look at what one of these problems is going to look like. All right, so before we get into that completely, just a reminder, these are going to be two steps each. And there are two conversion factors that we're interested in. 1 mole of any substance is equal to 6.02 times 10 to the 23rd particles. All right, and remember those particles can be atoms, they can be molecules, protons, neutrons, electrons, whatever. All right. We also know that 1 mole of any substance has a mass equal to that substance's molar mass in grams. All right, so these are the two unit equalities we're going to use to set up our conversion factors down below. All right, just like we saw before, we're going to have some value that is given. All right, that's going to be given in the problem. And let's say that it's particles. All right, so when we set up our first conversion factor, we're going to need to convert that by putting particles in the bottom of that conversion factor. All right, so we're going from particles to moles, so moles need to be in the top, and this is going to use Avogadro's number, where we know that 1 mole of any substance contains 6.02 times 10 to the 23rd particles of that substance. All right, but we're not finished yet because the problem asked for that answer in grams. All right, so we need to now do a second conversion factor. This time we'll put moles of our substance in the bottom and grams of that substance up top. That's going to let us cancel those moles, cancel those particles, and we'll be left with grams of that substance. All right, now that grams and moles unit conversion factor, 1 mole of any substance is equal to the molar mass of that substance in grams. So we'll need to calculate that molar mass. All right. But what if instead we want to go from grams to particles? All right. So we're going to be given grams in the problem. So our first step will be to put grams of that substance in the bottom of our first conversion factor. All right, this time we're going to go from grams to moles. So moles will be up top. And we know that 1 mole of any substance is equal to its molar mass in grams. All right, so that'll let us cancel the grams, but we're not done yet. We need to convert those moles. So we're going to put moles in the bottom of our second conversion factor, and particles will go up top. And we know that 1 mole of any substance contains 6.02 times 10 to the 23rd particles. So that's going to let us cancel the moles and leaves us with particles, which is what the problem is asking us to do. All right, so you can see it's taking the two problems we did separately and putting them into a single problem. Okay, so what do these problems look like? All right, so we're going to do a couple of these for practice. All right, my strong suggestion is you do as many of these as you can, because the more practice you get, the better off you're going to be. All right, so let's start with this problem. We've got how many atoms of sodium are in a 100-gram sample. All right, so we've been given 100 grams of sodium, and we've been asked to calculate the atoms of sodium. All right. We don't have a unit equality that lets us go directly between those two. So there's no one-step problem that we can put together that lets us make that conversion. Instead, we're going to need to convert those grams into moles of sodium, and then we can go to atoms. So we'll need the molar mass of sodium, and we're going to use Avogadro's number to make that happen. All right, so we start with what we have been given. All right, so 100.0 grams of sodium. And our first conversion factor, we're going to put those grams in the bottom. So grams of sodium in the bottom. And we said we're going to moles of sodium, so that's going to be up top. All right, so this is our molar mass step. All right, so it's a single element. So I just need to go to the periodic table, and I see that 1 mole of sodium has a mass of 23.00 grams. All right, so that'll let us cancel the grams, but the problem asked for atoms. All right, so we're not done yet. We need to do a second conversion. All right, this time moles of sodium will be in the bottom and atoms of sodium will be in the top. And according to Avogadro's number, 1 mole of any substance contains 6.02 times 10 to the 23rd atoms of that substance. All right, so we'll be multiplying 100 times 6.02 times 10 to the 23rd. And then we're going to divide that by 23, that molar mass. All right, and we're going to get 2.62 times 10 to the 24th atoms of sodium are present in a 100 gram sample of sodium. Okay. All right, so not too bad. It's a little more complicated, but again, we're just going to be following the unit. So if we can keep that in mind, we should be in pretty good shape. All right, so problem 2, how many molecules are in 23.1 grams of water? So we have 23.1 grams of water, and we're asked to find how many molecules of H2O we have. All right, again, there's nothing that equates mass and particles, so we can't go directly. So our first step will be to convert to moles of H2O, and we'll do that with the molar mass of water. All right, and then we're going to convert to molecules using Avogadro's number. All right, so this is going to look pretty similar to the one we just did, except instead of an element, this time we have a compound, so we'll need to calculate its molar mass. All right, so we start with what we have been given. All right, we have 23.1 grams of H2O. Our first conversion factor is going to put those grams in the bottom. And we're trying to figure out moles. That will be up top. All right, now the molar mass of H2O. So I have 2 times 1.01 for the hydrogen plus 16. All right, so I have a molar mass here of 18.02 grams per mole. So that means for every 1 mole of H2O, it has a mass of 18.02 grams. So that's going to let me cancel the grams of water. All right, so up next, I'm going to take my moles and put those in the bottom. So moles of H2O in the bottom, and my molecules of H2O are going to be up top. And this is where we use Avogadro's number. 1 mole of any substance contains 6.02 times 10 to the 23rd molecules of that substance. That's going to let me cancel the moles. All right, so whoops, not times, equals. So all I have left now are molecules in terms of my units. So 23.1 times 6.02 to the 23rd. And then I'm going to divide that by 18.02. All right, and I get 7.72 times 10 to the 23rd molecules of H2O. All right, so if I measure out 23.1 grams of water, that sample is going to contain 7.72 times 10 to the 23rd molecules of water. All right, so now let's try one where we want to know what is the mass when we're given the atoms. So what is the mass of 2.87 times 10 to the 23rd atoms of magnesium? All right, so I have 2.87 times 10 to the 23rd atoms of Mg, and I'm asked for the mass in grams of Mg. All right, so as we saw before, there's no direct root between those two units. So my first step will be to convert to moles of magnesium. So atoms to moles, that's going to require me to use Avogadro's number. All right. Then moles of magnesium to grams of magnesium, I'm going to need the molar mass of magnesium off the periodic table. All right. So again, I start with what was given. So in this case, 2.87 times 10 to the 23rd atoms of magnesium. And my first conversion factor is going to use those atoms in the bottom. And I said I was going to the moles, so moles will be up top, right? And according to Avogadro's number, 1 mole of any substance is equal to 6.02 times 10 to the 23rd, in this case, atoms. So that'll let me cancel my atoms. All right, but I'm not done because the problem asks for the mass. So I'm going to take those moles. They're going to become the bottom of my next conversion factor, and grams of magnesium will be up top. All right, if I look at the periodic table, it tells me that 1 mole of magnesium has a mass of 24.30 grams. All right, so that'll let me cancel those moles. All right, so now I'm going to plug in 2.87 times 10 to the 23rd. And then I'm going to multiply that by 24.3. I always multiply across the top and then divide by each thing on the bottom. All right, now I'm going to divide that answer by 6.02 times 10 to the 23rd. And I find that I have 11.6 grams of magnesium. All right, so if I have a sample that has 2.87 times 10 to the 23rd atoms of magnesium in it, it should have a mass of 11.6 grams. All right. How many formula units are in 45.5 grams of C2H5OH? All right, so this formula units, all right, that's another way to talk about molecules. So that means we're trying to go from mass to particles. All right, so we've got 45.5 grams of C2H5OH. And we're asked to convert that into, I'm just going to write molecules here, C2H5OH. All right, as we've seen, there's no direct path. So the first thing I'm going to do is convert to moles of C2H5OH, which means I'll need to calculate the molar mass. And then I can go to molecules using Avogadro's number. All right, we start the problem with what we have been given. So we have 45.5 grams of C2H5OH. Our first conversion factor is going to put that unit in the bottom, so grams of C2H5OH, and we'll be converting 2 moles of C2H5OH. All right, so I need to calculate the molar mass. All right, so let's see, I have 2 carbons at 12.01 each, plus 6 hydrogens at 1.01, plus a single oxygen at 16. All right, so 24.02 plus 6.06 plus 16. So I have a molar mass here of 46.08 grams per mole. So in other words, 1 mole of C2H5OH has a mass of 46.08 grams. All right, but I'm not done. That lets me cancel the grams, but I still need to get to particles. All right, so I'm going to put moles of C2H5OH in the bottom, and I'm going to put molecules of C2H5OH up top. I'm running out of room here. All right, and I know that 1 mole of any substance contains 6.02 times 10 to the 23rd particles of that substance, in this case, molecules. All right, so that moles are going to cancel, and I'm left with molecules of C2H5OH. All right, so now it's 45.5 times 6.02 times 10 to the 23rd, and then I'll divide that by 46.08. And I find that if I have 45.5 grams of C2H5OH, it contains 5.94 times 10 to the 23rd molecules of that substance. Okay. All right, one last problem. All right, what is the mass of 5.65 times 10 to the 22nd molecules of AOH3? All right, because I don't have quite as much room, I'm not going to put the map together this time. I'm just going to start, whoops, with what I have been given, and we're going to work our way down to what we are looking for. All right, so 5.65 times 10 to the 22nd molecules of ALOH3. Our first conversion factor is going to put those molecules in the bottom. So molecules of ALOH3. And we're going to moles of ALOH3. And I know that 1 mole of any substance contains 6.02 times 10 to the 23rd molecules. So that'll let me cancel my molecules. All right, but I'm not done. The problem asks for mass of this substance. So this time, moles of ALOH3 will be in the bottom. Grams of ALOH3 will be up top. And I need the molar mass. All right, so I got to take a second. All right, the molar mass, 26.98 for the aluminum. And then I have 3 oxygens at 16 each, plus 3 hydrogens at 1.01 each. All right, so that's going to be, whoops, 78, whoops, 78.01 grams per mole. So in other words, 1 mole of this substance has a mass of 78.01 grams. I'm sorry, it's a little crowded there. All right, that's going to let me cancel my moles. I'll be left with grams. All right, so 5.65 times 10 to the 22nd times 78.01 divided by 6.02 times 10 to the 23rd tells me that I have a mass of 7.32 grams of ALOH3. All right, so in other words, 5.65 times 10 to the 22nd molecules of ALOH3 has a mass of 7.32 grams. Okay, so I hope you can appreciate that while 2 steps versus 1, they're not any new steps. These are steps that we have been working on. So I don't want you to be intimidated by multi-step conversion problems, because if you just follow your units, so in other words, your units should be diagonal all the way down the problem. What you start with should be in the bottom of your first convection. What you have in the top of that one should be in the bottom of the next one. And you just kind of walk your way down the problem, canceling as you go. Whoops, messed that one up. Right? And if you do that, then you should get the hang of how to work these problems. Okay? But for now, remember, if you need to go between moles and particles, you need Avogadro's number, where 1 mole contains 6.02 times 10 to the 23rd particles. If you need to move between mass and moles, you need to know the molar mass of that substance, where 1 mole of that substance has a mass equal to its molar mass. And then sometimes you got to do both of them, one after the other. But I know you can do it. All right, if you have questions, please let me know.